Carrie Roberts is a red teamer turned blue at Walmart. She is now using her adversary simulation skills to improve detection and defense. She obtained a master's degree in information security engineering from the Sands Technology Institute in 2015 and holds the GIAC Security Expert certification. Carrie is a frequent speaker at industry events and loves giving back to the InfoSec community. Now, Kirk Sayre is a member of the Dynamic Defense Engineering team, where he focuses on the detection and analysis of malicious MS Office documents. Kirk is one of the primary maintainers of ViperMonkey, a VBA macro emulator utility. Kirk's educational background includes a PhD in computer science from the University of Tennessee, where his research centered around using statistical methods to improve the testing of software. With that being said, coming to the stage to give their presentation on advanced malware VBA stomping, what's new in 2019, please give it up for Carrie Roberts and Kirk Sayre.
All right, good afternoon, everyone. I hope you all had a good meal and are all ready for an exciting dessert treat of how to make malicious Office documents harder to analyze and detect. So Carrie and I are going to be talking about some advances in work that we presented this past fall at DerbyCon. And so this is a technique which can be used to modify malicious macro-enabled Office documents to make them harder to analyze and harder to detect. So, have the obligatory disclaimer at the start of the talk. The techniques that we're going to be talking about are things that could potentially be used to do something bad. So disclaimer says, don't use them to do anything bad. All right, so as an introductory recap, the basic idea behind the VBA stomping that we're going to be presenting is that inside a macro-enabled Office document, the information about the macros is actually stored in two different ways inside the document. Okay, so one way that it's stored inside there is as like a raw compressed string that just contains like exactly character for character what all of the original source code for the macro looks like. So that's in there. It's easy to pull out and work with. And then there's a second way that these macros are stored in the document also. They're also stored as in a compiled format, which is compiled to P code. And so this is a pseudocode for a proprietary low-level Microsoft virtual machine. And this compiled P code version, that is what actually winds up executing the majority of the time whenever you enable a macro in a document. So the source code that's in there, that is, in most cases, ignored by Office whenever you open the document and enable the macros. So that's the way that Office uses those two different ways of storing the macro inside the document. Flip over to the detection side. Most AV scanners base their detections on the compressed source code that appears inside the document. So we have that interesting mismatch there where the focus is different between AV detection and what's actually used. And so you can probably guess that's where we're heading with this VBA stomping idea. So this work about the P code and how the macros are stored inside the document and things like that, that is all based on a lot of really detailed foundational work that was done by Dr. Bonshev. And he actually spent the time to grind through the undocumented P code instruction set to figure out what the instructions are, how it's laid out in bytes inside the file, and wrote a disassembler for P code. So we make heavy use of the foundational work that he did. So now down at the bottom of the screen, we have like an example of the two different ways that the macros are stored inside the file. So over there on the left, we have the original source code. So this is what you see whenever you open up the macros inside the IDE for Office. And that text that's down there, the sub auto open that pops a message box, that string with all the white spaces, everything is then stored as a compressed string in exactly the way it appears in the editor inside the source code section of the document file. Now over on the right, we have, this is what is actually typically run whenever the macro executes. So this is a snippet which is pulled from the output of Dr. Bonchev's P-code dump disassembler. And so you can see that this is looking a lot more like assembly instructions, if you've ever done anything in assembly. And for this simple example, you can, it's kind of obvious the correspondence between the P code and the source code. We have the function definition, or we're pushing ABC onto the stack, and then we're calling message box to go and display ABC on the screen. So what does this VBA stomping, what does that do? So what this does is that knowing that most of the AV scanners are looking at that source code section and not the P code that typically executes, you can just go in and write a bunch of garbage bytes over top of that source code. And the document, if you open it with the same version of Office as the document was created in, macro will run perfectly. Any sort of AV, which is based on looking at the source code, is just going to see garbage there. It's not going to match any signatures. It's going to think it's fine. So what we have here is, look on the left part of the screen, is what a user that was being very diligent would see whenever they get a macro-enabled document. They're unsure if they should actually enable those macros in there. So they bring it up in the IDE in Office. Before enabling the content. They look at it and they say, oh, well, this thing claims to have macros in it, but it looks like they didn't actually put any code in there. This looks perfectly fine, so let's click Enable Content, and then all of a sudden, oh no, all your files belong to us, where us is not the organization you're working for. It's an organization that you do not want to have all your files. And you know, one interesting thing here is, if you look at the code section in the IDE, once the content is enabled, Office is very helpful. It notes that there is a difference between the source code in the file and the P code, and it then goes and says, I'll help you out. I will go and disassemble the P code and give you back the original source code. So this helps out in responding to an incident, but since you don't see that before enabling the content, it makes detection more difficult. So from an attacker standpoint, like what sort of value do they get out of doing this? So what we have up here is as a simple example where up at the top we have a macro-enabled Excel file. And this has a simple little macro in it where all it does is call shell to pop calc whenever the person enables the macro. So this is doing like enough actions that there are 3 AV engines that look at what it's doing. It's doing a shell call that could be suspicious. So 3 of them flag that as this is malicious, you shouldn't enable that macro. We go in and write over that source code with a bunch of garbage, leave the P code right there so that if you were to open it, it will still pop calc, and that now drops those detections down to 0. So we've now dusted off those 3 that said it was bad, and now everyone says it's good. You're perfectly safe. Feel free to run that whenever you want. So here's a little recap of the advances that have been made in this VBA stomping area since we gave our original talk in fall of 2018. So in 2018, the way that we were doing this stomping of the source code was all purely manual. We would bring it up in a hex editor and go in there and type bytes directly into the file. At that point, we were only able to just stomp on the source code, which is just overwrite it with some arbitrary garbage bytes. And if you were to try to extract it and look at it, it would just look like a bunch of junk. And then, like I mentioned briefly before, this Office version dependency. So the P code is tagged inside the file with the version of Office and whether you're running a 32-bit versus 64-bit version of Windows. And if you were to try to open that document up on a machine that has a different version of Windows or a different version of 32-bit versus 64-bit, the P code would not be valid for that version of Office, or it is being very, very conservative and it thinks it's not valid. So the way things are supposed to work is that it will then pull out that source code, recompile it to the proper P code version, and then run it. So this meant that in 2018, these stomped documents would only work on target machines that had the same version of Office, same 32-bit versus 64-bit as used to create the document. So in 2019, there is a team at Outflank Security that had also been doing work in this space. And so they have worked up a tool for doing automated stomping of documents. They figured out how to not just stomp the source code, but to replace it with your own arbitrary VBA macro code that you want to have show up in that source code area. They've also figured out how Office tracks and represents the version information for the P code so that their tool allows you to choose which version you want it to claim to be for the P code version. We've also figured out an anti-analysis technique for how you can lock the VBA project so that when you try to bring it up in the IDE, it will say that there is no way for it to display that to foil analysis. And then finally, so there's been lots of offensive side, red team side here. We've come up with a YAR rule, which is going to be able to detect that stomping has occurred in Office 2000 plus files. So right now there are two tools which will perform stomping automatically. The top tool, the Adaptive Document Builder, is something that was developed here at Walmart. And this is a Python tool for use by red teams to test the detection mechanisms you have on your system. And it allows you to specify the malicious payload that you want to run, choose the document builder that you want to have generate the VBA source code. And we have several different document builders that we wrote that mirror the types of documents that are built by campaigns such as Emotet and things like that. And then you can say, write me out 400 random documents that are all different, have all different macros, but all eventually run the same payload. We've added an option to that, where you can say to stomp the source code in all of the generated files. And this is an open source tool. We have that available up on GitHub. Now, Outflank Security has written a tool called Evil Clippy. And Evil Clippy is a cross-platform binary written in C#. We've used the version that runs under Windows and Linux. I believe it also runs under Mac. And it allows you to provide your original malicious file that has the macro functionality in it that you actually want to run. You also provided a file that contains the good, nice, friendly-looking VBA macro code that you want to have replace the source code. And it will then go in and overwrite and replace the source code that's currently in the malicious document with the safe-looking source code. And as I mentioned earlier, they also have functionality in there for you can specify the version of P code that you want the document to claim to be. And they also have some other functionality that we'll get into a little bit later in the talk, where you can dynamically choose which version of P code that you want to serve out for your stomped Maldoc. So Evil Clippy has a lot of functionality available in it that was not available in 2018. One of the big ones is that it can replace the source code rather than simply stomping and overwriting it. It has the ability to detect the proper version of the document to serve out to a victim. It has an anti-analysis option where you can lock the VBA source code so it is unviewable inside the IDE, and then some other things that Carrie will be talking in more detail at the end of the talk. So here's an example of, rather than just stomping on the VBA source, replacing it. So we have over on the left, again, we have a very diligent end user who checks everything before they do something. They're looking at the content of the VBA macros before they click enable content. They look down in there and they say, okay, it just has one function in there, the cuddly kittens function, where our kitten will give us a purr. The user decides, that looks great, kittens are awesome, I love kittens, they would never harm me, I'm going to go and click enable content. So they click enable content, and then, uh-oh, this is not actually a cuddly kitten. This is an angry, feral kitten, which is now hissing at us and doing other terrible things that cats can do if they get loose on your machine. So you'll see that, as we saw before, Office detected that there was a mismatch between the P code and the source code. Disassembled the original source code from the P code, and we can see after running this that we actually have an angry cat rather than a cuddly cat. So one of the difficulties with this VBA stomping method is that P code version matching problem. Unless you know exactly which version of Office in 32-bit versus 64-bit your target has, there's a great risk where if you deliver a document in there, it simply won't open, it won't work due to that version mismatch. So Outflank has addressed that problem by figuring out that there are 2 bytes inside the file that where it stores that information. They figure out where they are, did some reverse engineering to figure out what values correspond to the different combinations of Office version, 32-bit versus 64-bit. And Evil Clippy can now set those bytes based on user control to the proper version to match the Office version that you're targeting. Now, a neat thing they implemented is that Evil Clippy can run in web server mode. And in web server mode, whenever it gets any request, it will look at the user agent that's being used to connect to the server, see if it can pull enough information out of the user agent to determine the Office version and the 32-bit versus 64-bit, and then dynamically serve out the proper document version for that target. So we have here, this is an example of running Evil Clippy in web server mode. So we see there up at the top that we give it the web server option. In this case, we're running the web server on port 1343. With the -S option, we give the file name that contains the good-looking VBA code that we want to replace the bad VBA code with. And then testdoc.doc is the document that has the actual malicious macro functionality in it that we want to execute on the endpoint. So then going down on the display, we have cases where there are connections made to the web server. These are all using an Microsoft Outlook user agent. The Outlook user agent is great for doing this sort of work because it contains a huge amount of information about the system which is making the request. So you can see up at the top one, in that first red box, it's telling us Win64 x64. So, all right, good. We know that's a 64-bit OS. The second red box there, it's just going out and telling us that it has Office 2016 on it. Sweet, those are the two pieces of information we need to set those bytes to give them a 64-bit Office 2016 document that will probably run on their endpoint. And down the other ones are just some examples of 32-bit versus 64-bit, different Office versions. Evil Clippy is able to figure out that from the user agent and then serve up the proper version of the document. So I mentioned that there are some other neat functionality of Evil Clippy, and Carrie will now take over and tell you about that.
Thanks, Kirk. So just to recap a little, we talked about how after you do VBA Stomping, after you enable the macros, what actually ran shows up over there on the right. You can see the code that actually ran. So as an attacker, you don't really want that to happen because it's easier for them to figure out what bad things you're doing with this code and then stop you and get you out of their system. So, or you might be a developer who just doesn't want their code seen because you're embarrassed by your own code, or you don't want people, that's from my personal experience right there, or you just don't want people to mess it up, or steal your intellectual property. So there is a way to get Microsoft Office to get, when people go to the macro code environment and try to click on your project, it'll say project lock, project is unviewable. So this is pretty cool. There's another way to do it. You could add a password to your project, but you know, you've been able to Google a workaround for that for years. You know, you kind of have to play with the file on disk and flip some bits, but you can get that password to go away. But this one's pretty tough. There's third-party products that you can buy that advertise, we can turn this feature on for you. But it's not something that you can tell Office to do for you, so you can't go to a menu in the VBE editor and say, please lock my project. So you'll find these third-party software that say we can make Office display this and not let anyone see your code. So that's pretty cool, but when you read their documentation, they'll say, no, make sure you make a backup of your code and your document before you run our system on it, because this is completely irreversible. Once this is done, not only they won't be able to see your code, but you'll never be able to see it again either. So that's pretty cool if you're trying to protect your document. That's pretty cool if you're getting paid for the software to do it. It turns out it's really easy to just manually make a document display this for you. And actually, we found a way to make it reversible as well. So we added to Evil Clippy the ability to turn this feature on that you could pay for or do for free with Evil Clippy. But also, like, to help defenders, also a way to, if you got a document and you really want to see that decompiled code because it's much easier to read than the P code, then you can use this to get rid of those protections. And it turns out, as a bonus, that when you run Evil Clippy on this with the option to remove this VBA lock protection, it wipes out the password while it's at it. And so this can help you in your reverse engineering. Unfortunately, if you were trying to protect your intellectual property, this, I guess, is no longer a feature if they Google and find this. The details of how this is done are on a Walmart Tech blog that went out last week, or went live last week, and the link is down there, but all of these slides are already online. There's a link to them on VBAStomp.com, along with everything else we talked about is all linked from there. So, you know, that's easier than taking pictures of all these, all the slides and links are on there. So now a little word on detection. So as we mentioned, I recently moved from red team to blue team. So now I've got detection on the mind. So I was looking at this, and also Harold, who was a co-presenter with us at DerbyCon, had noticed that in some of these documents I had made that the the header of the file was a little different than he was used to seeing for something that actually came from Microsoft Office. So I looked into that. So more recent versions of Office, like from 2007 and on, they default to save Office documents really as a zip document. You can change the .doc to .zip and unzip it and see a bunch of files that describe the document. So these are really zip documents, but the interesting thing is when Office zips up a file, it does it in a little different way than anything else I've tried. 7-zip, different PowerShell ways of doing it, Python, WinZip, the built-in Windows zip tool. So when Office zips a file, then what we've got showing here is the file header for a zip file. And a piece of that file header, there's a couple bytes that describe the length of some optional extra data you can add in the header. Well, most tools just set that to 0 because they don't have anything interesting they want to put in there, but Microsoft Office, and I tested from 2003 up, they all use a non-zero value there and throw in some extra data. So this is a way that we might be able to detect that this document has been tampered with. So anybody who's manually unzipped this, tweaked some bits, and zipped it back up is going to have zeros there. So we wrote a YAR rule, and a YAR rule is like a industry standard way of describing what you want to search for in a file. So if there's certain text or bytes that you want to look for in certain spots in certain ways that might indicate that something is malicious, you can use YAR as a way to describe what you're looking for. And then you can feed these YAR rules to a lot of different types of tools like firewalls to say alert me or block if you see these kind of files coming through. So this is what the YAR rule does. So on line 11, you see that's the main part of this rule. It's looking for a zip header with 0 extra field length. So that extra field, 2 bytes, if that is 0, and in addition, this is not just a zip file, but it's actually an Office document with macros in it, then we're suspicious of this document. So it's not exactly a VBA stomping detection, but it's a detection of Office file that has had some tampering and weird stuff that you might want to take a closer look at. And I've been running this rule on VirusTotal, so it's run on anything new thing that's uploaded every day. I've been running it for a few weeks. And it gets a handful of detections, and there's several of those that I've downloaded myself and confirmed that they are VBA stomped. So this is happening in the wild. You can pull down real samples, and there's links on VBAstomp.com to those VirusTotal samples that are in the wild that are VBA stomped. So just as a summary, the VBA stomping is a cool technique to, trick a user into enabling something. I know if I get a macro-enabled document, I always felt warm and cozy when I went over, and I felt smart. Looked through the code like, yeah, this is fine, especially if it was a coworker who sent it to me, because those were red teamers, and that can be scary. So you always want to check these things. But now I realize that I could have been completely tricked into saying hi to my cuddly kitten. So it also is a big deterrent to reverse engineering, because it's a lot harder to understand the P code, and a lot of rules break. A lot of tools break in trying to analyze this, and even in the last year, a lot of those tools have been fixed to realize that, instead of crashing, to be a little more helpful. But it's still a deterrent to reverse engineering, and we showed examples of how it helps. If you've got antivirus that's only looking at the source code, and you can make that whatever you want, as benign looking as you want, but really the bad stuff is really there, and then it's a good antivirus deterrent. And this can be easily automated with a few tools. Evil Clippy's got several extra options that are handy, like removing VBA locked and passwords for you. There are some detections you can look into for detecting this malicious stuff. And then check out VBAstomp.com, because we keep that updated with just stuff related to VBA stomping to make it easy. So we've got links to our DerbyCon presentation, to some ISC blogs from others, and the Outflank work, and the Evil Clippy tool, ADB, I also added a link to my GitHub repo that has about 50 sample VBA Stomp documents, and that's for all versions of Office, all versions, 64-bit, 32-bit, Excel, Word, old 97.doc format versus new zipped docm format. And so that can help you in your testing, investigation, playing with it. And those are just simple message box pop-ups, so those don't have malware in them. But then there's also links to samples from VirusTotal, and those are malicious, and so be careful with those. But you can look at some real-world samples there, and all that's on VBAStomp.com. And that's all we have for you today. Thank you.